right, so to kick this lesson off, I've opened up two files in VS Code. On the right-hand side, I have our app.js file where we have all of our components. And on the left-hand side, I have the index.js file in our source directory. Now, we previously opened up this file and kind of glossed over it. We talked about it very quickly. So in this lesson, I want to return to this file and talk about it in greater depth because we now have a better understanding of JSX and can have a better understanding of what exactly is going on in this file. So I promised we'd come back and talk about it in greater depth, and here we are. Let's just walk through it line by line. On the very top, we are importing React. Remember, we no longer need to do this if we're just using JSX, but as it turns out, we are using a property on this imported React object down below, so we do need to import React literally in this file. Then we are importing something called React DOM, and the reason why there's separate libraries is because React can exist in multiple ecosystems or rendering environments. So as you may recall, there is a package called React Native that allows us to use React on mobile applications on iOS and Android devices. React can also work in the browser with the browser DOM. So the core fundamental React library that we have on line 1, that just handles things like JSX and various component features. The actual part that renders those React elements to a screen, right, to a location, that's handled by different libraries. So React DOM specifically here deals with rendering React in a browser environment with a DOM, with a document object model. If we were using React Native, we would still use React, but we would swap React DOM with the equivalent from React Native that renders React to a mobile screen, right, to a mobile device. Then on line number 3, we are importing a CSS file. That's just enabling access to certain styles in our app. Then on line number 4, we are importing our app component. So if I scroll down in my app.js file, you'll see that after we declare our app function component, we are making that the default export of this file. And we can import our functions the same way we do in regular JavaScript, right? This is a default export. So we import it right here without curly braces directly from the app.js file in the same directory. Now, this report web vitals thing on line number 5 is dealing with performance tracking. It's really an optional add-on, and we don't really have to worry about it right now. So for now, we can actually remove line number 5 and also remove the use case for it down below. This is just telling you a little bit more about it, how you can track performance in the React app, speed things, how quickly things render to the screen. It's more of an optimization thing that doesn't concern the core fundamentals of React. So for now, we don't have to worry about it, and I'm going to delete it. So that leaves kind of the remainder of this file, lines 6 through 11, and this is really the heart of what's going on in this file. So what we're doing here is we're using a method on the React DOM imported object called createRoot. And what that's going to do is create the root or the foundation of a React application somewhere in our browser DOM. Now, React DOM needs to be told where it's going to initialize this React application, so we need to provide it a valid DOM node. A valid DOM node is just some kind of element on the screen. As a reminder, what we're doing here is using a browser object called document and its getElementById method to find an HTML element on the page with an ID of root. That is defined in our index.html file. The user will receive this file. So down here, we have that div with an ID of root. That's what we are querying for right here. And once we identify that DOM node, we are passing it into React DOM so it knows that it's going to create the root or the foundation of the React application in this position. But just because we've latched on to this section of the screen, this empty div, doesn't mean that React DOM knows what it should render, right? Because we can have 100 different components in our application. How is it supposed to know what it should actually render within that div right there, the div with an ID of root? So once we get back this root object from the createRoot method, on the next line we call render, and to render we pass JSX. And that JSX, of course, represents the component or components that we want to render in that location. Now, when you're dealing with any kind of chunk or slice of JSX, you must always have one top level element. So what I mean by that is you can't do something like this where, for example, we have two apps being rendered one after the other. So I can't do something like this, right? Because that means there's two top level elements, and that's an issue with React. So if I hover my mouse over it, you can see it says JSX expressions must have one parent element. So If we have a situation like this, we always must have a parent element that is nesting or housing these children in order to make this possible, right? It's kind of the exact same principle in HTML, where we can't do something like render, a body tag and then also a body tag at the same position, right? It has to be intrinsically follow a nested structure. Even in HTML, we start with the idea of starting with HTML at the very top and then nesting everything within it, right? It's sort of the exact same principle with JSX. So if we return back to what we have right here, this is totally valid because we're starting off with a component. We'll talk more about this component in just a second. And then inside it, we are specifying to render the app component. So this is the exact same syntax that we've now experienced in our app.js file for all the other components, right? So for example, in the app component, we are using that self-closing tag to render the header component. In header, we are rendering the logo, text, and link components. So in index.js, we are finally rendering the app component. This is where everything kicks off, right? So the only thing that's really left to explain here is what strict mode is. Well, as you might guess, simply from the syntax alone, strict mode, which is available as a property on the React object that we import, strict mode is a React component. It's a React component that is built into the React library that we are importing here and using. And as we mentioned earlier, we can have self-closing tags in React, but we can also have opening and closing tags. And in this situation, we are utilizing them right here. So this strict mode is the beginning of this component render. And then we're having a child component rendered inside it. And then we're closing the strict mode component. Now, here's what's really cool about strict mode. It's actually a component that doesn't render anything visually to the screen. Rather, this is a component that's going to check for various violations in the children that are being rendered between its opening and closing tags. So what strict mode actually does is it looks for things like deprecated code in your components, such as app, and warns you about it in the browser console. And that should kind of get your brain juices flowing a bit, because it's starting to introduce a complex idea, which is that our components don't necessarily need to render something visual to the screen. Instead, they can do something like business logic or calculations or data fetching, right? Now, you might be curious, if a component returns JSX, how can it only do something like calculations or data fetching? And the answer is that a component can say, I'm still going to render JSX, but that JSX will simply be whatever my children are. So in this case, the app component is the child of the strict mode component. So somewhere in the React codebase where the React developers defined the strict mode component, they defined a logic for doing all this deprecation checking. And then for that component's return JSX, they say, whatever you give me to render as a child, that's what should be the return JSX of the strict mode component. We're going to learn how to manually do this in our own components later, but it's definitely an interesting thought experiment to consider that your component doesn't actually need to have HTML elements or a quote-unquote JSX being returned in order to function as a React component, right? A really good analogy that I can provide for this situation is whenever you're learning object-oriented programming for the first time, many instructors like to introduce the concept of physical objects in the real world and introduce them as classes. So we always have the animal class or the vehicle class. And the reason we do that is because it's easier for students to grasp something when it is physical, when it exists and we can touch it and feel it and see it, and thus imagine it being represented in code. Well, the next step in our developer journey when we're learning object-oriented programming is to understand that an object doesn't really have to be something physical. It can be something more abstract. For example, you can have a class to model a database query or a financial transaction or a round in a poker game, right? And those are not things that we can tangibly, physically see in the real world, but they can still make sense as objects in JavaScript, because all that an object is just a container of state and behavior. And a financial transaction or a database query can certainly have state and behavior even if we can't see it. Well, it's sort of the same principle here in that it's easier to begin our education on React components by imagining them as being just slices of the user interface that are visual, and they absolutely can be and certainly are, right? But they don't have to be, because a React component can also function as a component that simply handles some bit of logic or calculation or data manipulation or data fetching, right? Or even calculating some kind of conditional logic, and then simply say, I'm going to do this responsibility, and then I'm going to render some kind of children. The children are going to be the official kind of JSX that is being rendered, and I'm just going to do something extra or supplemental kind of on the edges of that render, on the outskirts of that render. So our components, as we're learning here with the strict mode component, don't actually have to render something visual themselves. They can delegate that responsibility to its child components. All right. Now, strict mode is completely optional, so we could actually just render app by itself like so, and that will work just fine. But for now, we're going to keep it. And this syntax, once again, should hopefully make sense because it's just JSX at the end of the day, right? It's just a component that is rendering another component, which is app, which kicks off this logic right here. And that's everything we see in our browser. All right. So hopefully we have a better understanding of how the entire application works. We start by receiving the index.html file. Then in our index.js file, we find that DOM node, we initialize the React app, and we tell React DOM what component should be the one that it is rendering to the screen. We're telling it here that we really want the app component, and that kicks things off right here. And that can render many different levels or layers of children, which simply mean more components that are being rendered within the given component. And that continues all the way down. And that becomes the entire React application that we see on our screen. All right, that's all there is to cover in this lesson. So I will see you in the next one.